Hey, hello, good evening. Uh, hello, Renee. There's only you here today. Apparently, 全部人去 holiday 了。Okay 啦，maybe they will come in later 啦，我不知道。Okay, hello. So 虽然今天是 holiday 啦哈，so our class will be as usual. Okay， 哎，为什么你 next week got exam 哈？OK，哎，这样你的 exam 是 cover 哪一个 chapter？给我知道一下。老师有讲吗？有讲吗？Until matter 啊，Until matter。OK，哦，就是今天我们要进的啦。整个 chapter 吗？整个 chapter 5吗？它会 cover 全部吗？因为我们supposedly 我们的 syllabus 是今天进 matter 啦。哦，OK， so most likely 应该是那个 three states 会进啦。Most likely anyway。OK， so anyway 我们今天来 start 我们的 Unit 5 States of Matter 哇，刚巧咯。你是下个礼拜几是 exam 啊？可能我们可以讲到你的 exam 那边。哦，next week，OK，这样可以啦，因为 by next week 我应该会讲完这一个 chapter 了。你看它才4 pages 吧？哦，next Thursday，OK，sure。这样惨咩 ？That means 你 holiday 没有去哪里啊？So sad 。OK，Anyway， 来我们来看 Chapter 5 States of Matter 这是一个 very easy chapter，very easy chapter。First 4 units 我们的 biology 已经讲完了。OK， 我们的 biology stuff 已经讲完了。那些 biology 的东西呢，可以说是读的时候很爽。OK，when you study 哇，很 fun 的。But when exam 就不一样 story 啊，因为 exam 很多东西写。But when it comes to like chemistry 跟 physics 我们现在就是进 chemistry So chemistry 跟 physics 很闲。你 learn 的时候很闲，因为很 boring 的。But 它的好处是 exam is really easy 因为这个东西很 straightforward 的。It is what it is， 你怎样看它就是这样出来的。OK，so anyway， 来我们看Unit 5 So what is a state of matter? So 我们的 5.1 states of matter I'll try to go English here because I need to send recording to my other students too. Okay, so campur lah Chinese, Mandarin and English lah. So anyway, number 1, everything around us is made of matter. Okay, so what's matter? Matter means anything that is made from atom. Okay, 物质 in Mandarin is called 物质。Okay, so matter so matter is anything that has mass and occupies space. This point if you want, you can memorize lah. If you want, you can memorize. So has mass and occupies space. All right. So everything around you is a matter. So all living things, including animals, plants, humans, are classified as matter. Why? Because you have these two characteristics. Do you have mass? Yes, you have mass. Do you occupy space? Yes, you occupy space. Right? So many things around you, they are matter. As long as they have these two characteristics, they are matter. So next, non-living things such as air, water, soil, stones, they are matter. Even air is matter. Air around you is matter. 你周围的空气都是 matter. 为什么呢？ Do air have mass? Does air have mass? Yes. 空气是有质量的。Maybe a balloon is like 20 grams, very lightweight, but they still have mass. And then, do they occupy space? Yes, they do. Right? Because air, you see, this is my bottle, this is air. They will still occupy space. So yes, air is a matter. Right? Although you cannot see them, they are still matter. Right? So anyway, non-matter does not have mass. It is have typo, and does not occupy space. So if you do not fulfill one of these, then you are not a matter. 没有满足到其中一个，你就不是 matter. For example, heat, okay, light, vacuum, sound, gravity, temperature, shadow, time, feelings, thoughts. These are not matter. Why? Because they have no mass, they don't occupy space. Right? For example, these three are, okay, these three are, they're actually energy. 它们是能量. Heat is energy, right? Light is energy. Sound is energy. You have heat energy, 热能, light energy, 光能, sound energy, 声能. These three are, they have no mass. You don't say, oh, this light energy is 5 kg. No. It is an energy, it has no mass. And then does it occupy space? No. Okay, no. So these things are, they are not matter. 它们不是 matter because they are not made from atoms. Energy is not made from atoms. All right, and of course, these things are, okay, feelings and thoughts, they have no mass. Okay, so anyway, let's look at our main point. Matter exists in 3 states. Okay, 3个形态. Matter has 3 states. Matter 有3个形，物质有3个形态。That is your solid, liquid, and gas. All right, solid, liquid. Hang on, just a moment. Someone is joining us. Just a moment. Yes, Asia. Hello. Good evening. Wow, I thought you're not coming. Although there's not many people here today. Wow, this holiday mood is real. Because this is not just, it's not just this class. All my classes are, many they are not coming. They are all in vacation now. All right. So yeah, Asia. Hello. What brings you here? Why are you not in holiday? Why are you not in vacation somewhere, enjoying the beach or the sunlight or whatever, enjoying the sea? I wish I can. Oh, no holiday, huh? Okay. Then, well, let's learn, all right? So anyway, Asia, Asia, are you having any exam soon? Are you having any exam soon? What school are you from, by the way? Have you mentioned your school? I forgot where's your school. So are you having any exams soon? And Sri does match. Okay, Sri does. Oh, following week. So what chapter do they cover? What chapter do they cover? Because see if this is until we are in chapter 5 today, by the way. Okay, chapter 5. I hope you guys receive your physical notes already because I've set it out like last 2 weeks ago. So by now you should have received it, but no guarantee lah. Sometimes you know lah, okay, there's delay every now and then. Okay, so anyway, they cover 3 parts. So your school is like the other way around. That means bio they will cover maybe 1, and then chemistry 1 and physics 1, something like that. Is it? Okay. So that means, all in the same paper. Yeah. What I mean is, that means they will come out 1 chapter in bio, 1 chapter in chemistry, 1 chapter in physics. Is it like that? Because most of the time it's like that lah. It depends on your school. Because some schools, okay. I see. Because some schools they will do everything bio and then they will do everything chemistry, everything physics. Okay, but mine is a bit different lah. All right. So no matter, guys, because at the end of the year, you are still learning the same thing. All right. It's just that our progression is slightly different. All right. So I believe this chapter is for sure coming out, Aisha. Right. This is the states of matter. All right. So anyway, as I was just saying this lah, matter is anything that has mass and occupies space. All right. So everything that fulfill these 2 requirements, they are matter. For example, animal, plants, humans, air, water, soil, stones. Right. So if you do not have mass or do not occupy space, like for example, heat, light, vacuum, sound, gravity, temperature, shadow, time, feelings, thoughts, then they are not matter. All right. So we were just in this just now. So this is one of the main point. Matter exists in 3 states, which is solid, liquid, and gas. I am sure in primary school you have already know this. So there are 3 states of matter, or we used to believe there are 3 states. There's actually 5 states of matter. But anyway, that is like advanced chemistry already. You have actually 5 states of matter, but now we are only learning 3, which is solid, okay, liquid, and gas. So as you know, H2O, which is water, right? I mean, in room temperature, there are water lah. So water exists as a liquid at room temperature. When they are at freezing point, which is 0 degree Celsius, they are in water. Sorry, they are ice. Okay, they are ice. They are solid ice, solid water, which is ice. So 0. And then when they are at boiling point or steam point, they will change into steam. All right, so steam is water in a gaseous state. All right, so they are 3 of them. They are all H2O. They are the same. They are chemically the same. They are the same chemical. It's just that the state is different. Okay, solid, liquid, and gas. This is the main part of this chapter, which is very easy. So let's look at our 5.2 particle theory. All right, this is a very important part for you to learn. So matter is made up of very fine and discrete particles. All right, what does it mean? That means if we zoom into something, we keep zooming in and zooming in and zooming in, you will come to a point that it is so small that you cannot zoom in anymore. So what's that smallest thing you see, which is that atom you see? So atom is a type of particle. Okay, particle. In Mandarin, it's called 分子. So this is your particle. All right, so that means, okay, very easy to understand this. You take a piece of paper. All right, take a piece of paper, you cut it into half, and you cut it into half some more, half some more, half some more, half some more. You keep cutting it in half. Eventually, it will get to a point so small that you cannot cut it anymore, right? I mean, it's quite far away, but once you get to that point that is so small you cannot cut it any smaller, that is a particle, right? That is a particle. So particle is something really, really, really small. So particles of matter, they move or vibrate constantly. So they always move, okay? Even in solid, they move. In liquid, they move. In gas, they move. It's just how fast they move. All right, so this is your particle theory. Okay, particle theory. Why is it called a theory? Because it is the most widely accepted idea, but no one has seen it before. No one has seen particle before. Why? Because they are too small. Too small, really, really small, so we cannot see them. All right, so let's look at solid first. As we said just now, you have solid, liquid, and gas. All right, so let's look at solid first. As you can see, solid, they are like hard. All right, steady shape. They won't just flow like water, so that's a solid. Okay, so in solid, particles are arranged very close together, as you can see here. They are so close that there's no more space to become closer. So they have strong force of attraction between particles. What is the force of attraction? Please take note of this word. Force of attraction, they are the attractive force between two particles. Okay, the two particles. That means, okay, think of it this way. If you are a particle, your friend is another particle, the friendship between you guys have this friendship, right? The friendship is the force of attraction. In solid, they are very good friends, right? They are all very good friends because they all live together. They are all very tight, very close together. So you can see they are all very good friends. So strong force of attraction, strong friendship, very strong, very, very, very good friends. So number 3, particles in solid, they cannot move, as you can see. Can they flow freely? No, leading to their fixed shape. Since they cannot move, right? So they have this fixed shape. So they cannot go anywhere. They can only vibrate at their fixed position. So does it mean solid, they don't move? No, they still move. It's just that they vibrate. Okay, these particles, they will vibrate at their position. So you see, they're still moving. It's just that they're not as fast as your liquid or solid. Just vibrate at original place. All right, and then since the particles are so close to each other, they cannot be compressed. All right, so imagine solid is like a bus full of people. All right, like full, really full. Every inch of the bus is occupied. So can you tell the bus and say, hey guys, can you guys stand a bit in some more? I want to squeeze another person in. No, not possible. They are already full. They are already close, very, very close to each other. There's no way for them to squeeze and get another place for you to stand. No, not possible. That's why solid, they cannot be compressed. You cannot compress solid. All right, you don't take a piece of solid, all right? Like let's say this solid is like, for example, 9 cm cube. You learn volume in maths, right? Can you compress this to 7? Can you press them smaller? No, you can't. All right, because there's no more place. So some might say, sir, then what about cotton candy? Why can I compress cotton candy? Because inside cotton candy, there's air, there's gas. You can compress gas, yes. All right, but solid, no. No. Can you compress a stone? No, you can't. You're gonna make a stone smaller. Not possible because they are already full. They are already full. They are already closely arranged. So there's no way for you to press them smaller anymore. So that's a solid. All right. So next, liquid. As you can see, liquid they flow. Not like solid just now in a cube. Now this is like flowing. Okay, like a river. So particles are close, but can slide over each other, making them flow easily. So the force of attraction, they're actually quite weak. Just now, strong friendship. Now, weak friendship, because you can simply just let go your hand, your friend will go somewhere else. So liquid is very weak. That's why it can flow nicely. So particles in liquid are close together. Therefore, compressing liquid is almost impossible. So does it mean that you can compress liquid? Still no, because you see, they're still close together. They are still close together. Do you see any space in between these atoms? No, you see, there's no space. Okay, there's no space. You see, got maybe a little maybe a little. That's why some liquid, yes, you can compress them, but just a little bit. Maybe 99 cm, you can compress 1 cm or 0.1, really small. All right, so liquid and solid, they are almost the same. You cannot compress them because there's no more space. Okay, like I said, it's like 2 buses full of people. Hey, can you guys stand inside a bit? Let me stand. No, you can't. There's no more space to stand. All right, it's just that the difference is solid, very strong friendship. Liquid, weak friendship. They can just run away from each other. All right, so that's a liquid. They are flowy. And then gas, they can just simply go away, you see, very free moving. So particles are very far apart, hence they spread out to fill the container. They can just fill the container. Very weak force of attraction. The friendship is not strong at all. Due to being very far apart, the spaces between the gas particles can be easily compressed. You can easily press them closer. Do you see all these spaces? Do you see all these spaces? It's like you have an empty bus. There's like 10 people inside. So you say, hey, can you guys sit a bit in some more? We have many people coming in. Yes, you can. You can easily press them. Because all these, they're empty space. They're empty space. So strong friendship, weak friendship, very weak friendship. All right. So this one, fixed shape. This one, there's no fixed shape. Okay, no fixed shape. This one can flow any shape. Gas also no shape. All right. So to summarize everything, you see, I made a table for you. This is the summary for everything. All right, before I move on, guys, in your exam, most likely they will ask you to draw. Okay, they will give you a box. They will give you a box and they will tell you to draw. Guys, please draw your atom as big as possible. All right. In this case, maybe you draw 9. Okay, you draw 9. Try to draw your atoms big. Why? Because you're saving time. Please don't be cute and draw something like this for me. Guys, I mean, if you don't mind drawing circles over and over again, yeah, sure, go ahead. But why? Why do this? Why not do this? You see, I have students who are so cute, they give me this. Yo, what is this? I mean, you draw it this way, you want to fill up this box, that would take some doing. It would take like, I don't know, 10 minutes to draw. Hello, this is only 1 mark. You know, in your exam, it's only 1 mark. Why would you get what I mean? Okay, there's no need for you to just draw circles over and over again. All right, so let's look at our comparison. As you can see, solid, they are very nicely arranged. Okay, do you see any empty space between them? Maybe, just very small. So do you think you can press them closer? No, you can't. All right. And for liquid, they are still close. Maybe there's a little bit of space between them, So maybe you can compress them, but just a little bit. But gas, as you can see, very wide open space between, so you can easily squeeze them together. So compressing is about squeezing. All right, so all these are already summarized for you. Like for example, arrangement. How are they arranged? They're very close. Solid is very close, as you can see here. Liquid, not very close, but still close. Still close. All right, and then gas is very loose, you see. They're not even next to each other. They're just running here and there. Wow. It's like you have 5 children running in the same football field. They just go crazy, run here and there. All right, because there's a lot of space. Okay, anyway, so next, space between particles. Okay, are there space between particles? Since they're very close, right? So they have very little space between particles, very small. Very small. And then liquid is moderate. I would still say they are small, but moderate. Okay, you see, they're small, a little bit more, just a little bit more. Whereas your gas, okay, they are very large. There's a lot of space in between, and this space is related to your compressibility. Please draw an arrow like this. Okay, draw it to your compressibility. That means if something can be compressed. Sorry, guys, this is my dinner. Okay, this is a protein shake. This is my dinner. Okay, so I'm actually quite hungry now. Okay, pardon me while I have my dinner and I teach you at the same time. Okay, so space is related to your compressibility. As you can see here, there's very little space here. So can you compress solid? No, you can't. Okay, no, you can't. Okay, think of it this way. If you have you tried going overseas and packing your luggage? Have you tried packing your luggage? Sometimes when you pack your luggage, if your luggage is like fully full, as in stupid full, you cannot even put one more thing inside. Do you think you can just simply squeeze them together so that you can put more stuff in? No, you can't. All right, I'm talking about properly folded clothes in your luggage, not just open your luggage and just chuck everything in, because I do that. All right, so you see, if you just open your luggage and chuck everything in, you're putting a lot of air inside. But if you fold everything nicely, you're just, you see, you're putting all solid inside your luggage. If your luggage is really full, can you just compress them and put some more stuff in? No, you can't. I wish I can, but no, you can't, right? Because you have no more space. There's no more space to squeeze, so there's no way for you to compress solid. Liquid, yeah, just a little, but still very difficult. Guys, you cannot compress liquid. Case in point, you take a syringe. You know what's a syringe, right? Okay, you take a syringe, you draw water in, okay, because syringe has that plunger, right? You draw liquid in, and then you close the entrance. You close the mouth, the tip, and then you press the plunger and see. Can you press liquid? No, you can't. All right, no, you can't. Maybe you can squeeze them by 0.01%, but that's about it. There's no way for you to squeeze liquid, because liquid, they are already very close. All right, the space is like only moderate or still small, so they are very difficult to compress. You can't really compress liquid, right? And of course, gas, this one easy lah. Since there are so much, there's so much space in between them, so they are very easily compressible. All right, you can compress gas and store them in a container. You know your aerosol spray, you know your mosquito spray. I'm sure you have that mosquito spray at home, right? That thing is compressed. The thing is air. It's gas. When you squeeze out the trigger, gas comes out, right? So you squeeze them and you store them in a container. Same goes to your cooking gas. You know your mom's cooking gas. I'm sure you have a big metal tank in your house that has your cooking gas, right? So the thing is actually compressed and stored inside. Gas very easily compress. Very easy to compress because there's a lot of space here. All right, movement. Solid, they can't move. They just vibrate. Like I told you just now, they just vibrate a fixed position. Liquid, they can move freely. Okay, they can slide nicely like that. Okay, do you know what is this like? You know your kiddie pool, kiddie ball pool. sometimes you go to some kind of playground, there's this pool full of balls, full of plastic balls. That's like your liquid lah. So they can nicely slide freely. Whereas your gas, they move even more freely. They are randomly, they just run everywhere. Okay, they just run everywhere and collide with each other. That means they bang into each other. All right, so volume, this one is fixed volume. Can you change the volume of this one? No, you can't. Liquid is also fixed volume because you cannot compress them. Whereas your gas, they follow the volume of the container. If the container is big, they fill the container. If the container is small, they will go closer. Gas is very easy to change. And then shape, solid has fixed shape because they can't move. Liquid, they follow container. Gas, they also follow container. Common sense, right? Your water just flow nicely in your container. Same goes to your gas. But solid, no, you can't just solid. They don't flow. They just stay there. All right. So compressibility, control it already just now. Attractive force. See this, like I said, this is strong friendship, right? So strong. Weak friendship, weak because they can just simply run. Very weak friendship, very weak force of attraction. Right? Right, that's it. Really, really easy. Okay, so that's your state of matter. This is the summary for everything. All right, so for exam, guys, you just need to read this one. All right, because this is just a summary of these. I mean, you can read these up, but I already summarized everything for you in the table. So you just memorize this table nicely. Okay, memorize this table nicely. You think biology easier than this? Is it? Hey, guys, here's the thing. Here's the thing. Girls really like biology one. I don't know why. Okay, I've been teaching for 13 years. Right? I've been teaching for 13 years. I used to teach separately. I used to teach biology, physics, and chemistry. Right? As in high level, I used to teach up to college. When it comes to biology, wow, it's like a girl's thing. I don't know why. Girls, when it comes to biology, when it comes to memorizing and learning factual stuff, facts, they are okay. But when it comes to physics, okay, physics, Aisha, I don't know whether you agree with this. Guys, when it comes to calculation, when it comes to maths, it's a guy thing. All right, when it comes to physics, when it comes to calculating stuff, when it comes to calculating, especially electricity. All right, next year, wait, is it next year? I think it's next year. Year 9, you'll be learning electricity. Oh, you will obviously see the difference. Usually when I teach biology stuff, my chat, all the girls will start asking questions. When I teach physics, the chat is quiet. No one is asking me anything. Okay, and then I'll be like, hey, what's wrong with you guys? What's wrong with you guys? They're like, sir, this one very dry, very boring, cannot absorb. That's the thing. You see, yes, very weird. Hey, you know, personal story, I graduated from engineering. Okay, I graduated from engineering. I graduated from civil engineering. Okay, you know what's engineering? Engineering requires a lot of calculation. If you are very good in maths, you are very good in physics, then you will be an engineer. All right, so I graduated from engineering. I don't know whether your family is like that, Aisha. For us Asians, there are not many career choices. Your parents will either want you to become a doctor, or they want you to become an engineer, or they want you to become a lawyer. That's all. That's the only choice you have. The rest is disgrace to family. You try and tell your mom, see, Mom, I want to be a dancer. No. What dancer, what kind of job? What kind of job is this? You think you can earn money from that? Okay, yes. It's either doctor or engineer. So I actually follow my mom's request. She want me to be an engineer. I actually wanted to be a doctor because I was actually more interested in biology. Okay, but too bad they didn't choose me. I mean, I applied for the scholarship, but they didn't choose me. So fine, I went for engineering. And you know what's the worst part? I studied civil engineering. Okay, civil engineering is when you learn how to build houses. Okay, we learn structures. Let's say a building has like 1,000 beams and columns. We have to calculate every column. Okay, what's the tension? How much force can they take? All right, it's like you are designing, let's say, a library. What's the maximum weight each floor can take? All right, how many books can you put there? How many people you can withstand? Right? It's like, let's say you're designing a shopping mall. How many people can stand on each floor before they collapse? All right, because if a building collapses, that's your problem. That's your responsibility as a civil engineer. All right, so when I was studying civil engineering, you will see something really funny. All right, in my hall, okay, because we go by hall, we don't go by class. Okay, one hall is around 100 something people. In my hall, that time, in my hall, there was around 120 students. Roughly 120 students It's like a lecture hall is like a cinema. It's like a cinema, it's like a theater. When you walk into a cinema, our lecture hall looks like that. All right. So you just look up into that hall, you will see almost all guys. All guys. Okay, because in my hall there were only 3 girls. Okay, I only have 3 girls classmates. The rest is all guys. All guys. All right. And those 3 girls they are the manly type. Okay, they are not that girly type girl. No, they are the manly type. Hey, my classmate as a girl she can carry cement. You know what's a cement? You know cement, right? You know people when they do construction you know cement, right? Hey, this bloody thing is 50 kg per pack. You know, it's 50 kg per pack. They can carry one each. Okay, so they are not your Barbie doll playing girly girl. No, they are like your muscular girl. So when you go engineering, you will see girls like that. All right. So you see, that's the funny thing. But when you go for biology related subjects, like if you go for medicine, let's say you want to be a doctor next time, you go for medicine, you go for pharmacy, you go for dietitian. You know what's a dietitian? You become a dietitian. That means you teach people how to eat. All right. Or you become a sports scientist. You know what's a sports scientist? That means if an athlete got injured, it's your job to teach them how to rehab their injury. Those you will see a lot of girls there. Okay, you see a lot of girls there. You'll see a lot of girls doctor, okay, girl physiotherapists, okay, you see girls there. But engineering, no. Civil engineering, I don't care whether it's civil engineering, chemical engineering. You know, chemical engineering is where you study like petrol. How do you work on petrol? All right. Next time you will work for companies like Shell, like Petronas, you work for petrol companies. All right. Chemical engineering or mechanical engineering, where you study machines. Okay, you study cars, you study planes, you study machines. What else engineering? Mechatronic engineering, where you study robots. Electrical engineering, where you study electricity. All these engineering, you will not see girls there. No, almost never. All right. So if you walk into an engineering school, it will be exclusively guys. Even the lecturer, which is the teacher, we don't call him teacher, we call him lecturer. Even the lecturers, they're all guys. All right. So Renee, when you say you like biology, when you think biology is easier, I know why. It's a girl's thing. Right? I can't explain why. This is how our brains are wired differently. Guys, we like stuffs like, we like geeky stuff. All right. I don't know whether Isha you are like that. Like me, I'm very interested in fixing stuff. All right. I like fixing stuff in my house. Let's say a rice cooker in my house broke. I will just open up everything. I will see how that thing works. If I will see how can I fix that thing. Girls are never like that. Girls are like, just buy a new one. All right, just buy a new one because I'm the engineer in my house. Chemistry is so hard and kind of boring. I know, I know. I know. Okay, you see, in my house, I'm the one fixing everything. I fix the cars. Okay, I fix the house, everything because I love learning how things work. But apparently, girls are not like that. I don't know why. I don't know why. All right, so girls are more biology. They are more towards biology. Okay, I would say I'm okay with all. Okay, if you ask me, sir, am I okay with biology, chemistry, or physics? I like them all equally. But girls are not like that. Okay, so Renee, you bear with me. I know this is a bit boring. Okay, hey, here's the thing, every year, year 7, year 8, and year 9, the first part is biology. Okay, you'll be having fun beginning of the year. And then as the middle of the year and the end of the year comes, when you start to learn chemistry and physics, you're like, oh my God, can we please be fast and get on with it? Unfortunately, no. Okay. Hey, at least I don't know lah, guys. I'm trying to make it as interesting as I can lah. But sometimes the nature of this thing like this thing you see, this thing itself is already very boring. I don't know lah. For me, it's interesting lah, but I don't know for you guys. Maybe Freddie, maybe for you it's boring. Then I can't do anything. All right, that's the best thing I can do. Okay. Anyway, let's talk about some fun facts, shall we? Let's talk about some fun facts. All right, you see, your attractive force, sorry, your state of matter, we used to think there are only 3 states of matter. We used to think. And then scientists actually discovered the 4th, which is called plasma. All right, that's actually the 4th state of matter, which is a plasma. Okay, do you know what is plasma? Fire is a plasma, right? Fire. If you say, sir, fire, where does fire belong to? Is fire a solid? Obviously, no. Is fire a liquid? Not really. Fire cannot flow, right? Is fire a gas? Maybe. But can you compress fire? No. Who has ever compressed fire, isn't it? So actually, fire is neither of these 3. Fire is a plasma. All right. So what is a plasma? Plasma is actually ionized gas particle. It is gas, but it is ionized. You may say, so what is ionized? Ionized, that means they have ions. What are ions? You have positive ion and you have negative ion. You know electricity? Electricity is the flow of ion. You'll be learning this you'll be learning about ions next chapter. Okay, next chapter, I forgot. Right, so that means if this gas has charge, that means if it is positive gas or negative gas, then the thing is called a plasma. Right? For example, your lightning. All right, that lightning thing, the electricity thing, that thing is a plasma. You know aurora? Guys, do you know what is aurora? The full name is called aurora borealis. Okay, aurora borealis. Oh, this thing is very interesting. Okay, so this aurora borealis. Aurora is in Mandarin, it's called 极光. You will see this thing in North Pole. Okay, you see this thing in North Pole. So what is this actually? Right. You see how pretty this thing is. You go to any northern country, you will see this thing. For example, if you go to Alaska, which is the US, you go to like any Nordic countries like Sweden, Norway, Greenland, Iceland, even certain parts of Russia, you can actually see this thing. All right. So how do these happen? All right. You see, do you know what else is a plasma? A sun is a plasma. Okay, because sun is a fireball. Fire is plasma, right? So you see, sun is very active. They have explosions all the time. That means when you look at the sun, sometimes you see them boom here, boom there, boom here, boom there. A sun surface will have explosions all the time. What if this explosion reaches Earth? We stay on Earth, right? If the sun's, we call it solar flare, it's the explosion on the sun. If the explosion reach Earth, it could kill us, The solar flare could kill us. But here's the thing. You see, we are protected by a layer of magnetic field. The Earth is a magnet. You shall learn this next time. The Earth is actually a magnet. You see, your Earth is a magnet. Why? Because a magnet has north and south pole, right? Your Earth has north and south pole, right? It's not a coincidence, because the Earth is a magnet. So you have a magnetic field around you to protect us from all these dangerous sun explosion. So when the sun explosion reach Earth, our magnetic field just push them away. Just our magnetic field will push all these dangerous explosion away. So when they push it away, when they push your sun explosion away, they will scatter this light, and you will get this thing called aurora borealis. All right, this aurora borealis. So last time, okay, a little bit fun story about this. The Norse, you know who's the Norse? Norse mythology. If you watch Marvel, you know who is Thor, Odin, and Loki. So last time, if you are in like Norway, Denmark, and all those, you know the Viking period. You know Vikings. Vikings, they don't believe in Christianity. They believe in gods like Odin. They believe in Thor. So they actually believe this thing is created by Valkyrie. Valkyrie is their goddess of battle. So they believe when you see aurora, that means Valkyrie just passed by the sky. That's what they believe in. All right, so that's mythology. It's like if you go to the last time Greece, Greek mythology, they believe in Zeus, they believe in Poseidon, they believe in Hades, they believe in Hera, Dionysus, okay, they believe in Hermes. So gods, all right? So this is what they believe in last time. Right? Turns out this is nothing to do with God, this is just sun. Okay, a sun's explosion pushed away by our magnetic field, you will get an aurora. All right, so make it your bucket list. Go to any northern countries, you can see them next time. If you're lucky, guys, this aurora, you don't see them every day. You don't see them every day. This thing is like a weather. All right, if you go to, let's say, Iceland or Denmark, you go there just to see this aurora. If you are very bad luck, you might see none in one whole week. Okay, for that 1 week you stay there, you see nothing because the sun doesn't create any explosion, so you don't see aurora. But sometimes when you go there, if you're lucky, if the sun's explosion is very active that year, you will see a lot of aurora. So it's a luck thing. If you're lucky, you will see this. If you're not lucky, then you cannot see this. All right, so this thing is a plasma. This thing is a plasma, and then of course a fluorescent light. Okay, this is the light bulb, and of course welding up. Okay, you know it's welding. You know it's welding. Sometimes now when they wear that mask and they join two metals together by producing spark, that thing, that thing is a plasma. All right, so this is the fourth state of matter. All right, that's actually the fifth state. Okay, that's actually the fifth state of matter. That thing is called your Newtonian fluid. Okay, Newtonian fluid. You might say, sir, what the hell is this? This thing, that's not even. This is not even a real thing. Newtonian fluid is not even a real thing. Okay, it kind of behaves like this, whereas when you punch it, this thing will not go in. So you will have a graph like this, right? See, this is what we learned in engineering. Last time when I was in engineering, I learned this, right? So don't ask me what is this. It's very hard for me to explain. Right, so you actually have 5 states of matter, but hey, you're only learning 3, right? You're only learning 3. Come on, guys, it's just solid, liquid, and gas. Okay, and I don't know about you guys, this is just like common sense, right? Sort of this is like just common sense So this plasma, just really for fun. This is just a thing I included here to, make your lesson not so boring. Okay, anyway, so shall we go into this? Hang on. I don't want to teach too much today because many people are not here. Okay, many people are still enjoying the holiday. Okay, let's go to our exercise, shall we? Let's go to our exercise. If I keep go on with this lesson, I think Renee will fall asleep already. Okay. I know, it's okay. Anyway, so let's go to page 5. Let's go to page 5. We'll try to do something easy today lah, because usually you have like 6 people here. Today is only 2 of you. Everyone is having holiday. So you two, you guys are the PT ones. All right. Anyway, so let's look at number 1. Write true or false for statement in the space provided below. So all living things are matter. Yes, it is true. All right. So whether are you a matter, then you have to ask yourself: do you have mass? Do you have kg? Yes, you are 60 kg, 50 kg. Do you occupy space? Yes, you do. As long as you have mass, as long as you occupy space, as long as you have these 2 characteristics, then you are a matter. So oxygen is a non-matter. False. Oxygen is a gas. Gas is a matter too, right? Because gas has mass, right? When you blow a balloon, when you weigh a balloon, does it say 0? No. A balloon is very lightweight, but it still has mass. All right. So it has mass and it occupies space. You see, I have air in my water bottle here. This thing will still occupy space. So that means oxygen is a matter. So next, a lamp is a matter, but light is not a matter. All right, true. Because a lamp has mass and occupies space, light does not. Light is an energy. All right, light is an energy. Do you have 5 kg of light? No, you can't measure the mass of a light. Do light occupy space? No, they don't. So they are not a matter. This should be pretty simple. So B, all living things are matter, but not all matter is living things. Explain why this statement is true. So 2 marks here. All right, so why are all things matter? Because all living things, all right, like I said, all living things have mass. You must have 2 characteristics. They have mass and occupy space. All living things, they have mass and they occupy space, right? I don't care whether you are as small as a bacteria or you are as big as a whale, you still have mass and you still occupy space. Yes, a bacteria might be very small, but they still have mass, maybe 0.0000001 kg. Who knows? All right, so but not all matter is living things. All right, so you can give an example. Stone is a matter, but it is not a living thing. All right, because stone, they have mass and they occupy space too. So they are matter too, but they are not a living thing. All right. Yes, this is very boring, I know. Okay. All right, so moving on. Well, this is too simple. Come on. Okay, so next, number 2. In the space above, draw the arrangement of particles in stone, coffee, gas, and in balloon. Come on, this is so easy. Like I said, if they give you a space, I'll try to draw it as big as possible. So I'm gonna keep it simple. I'm not even gonna fill out this thing. I'm just gonna draw 4 like this. And I'll draw in 3 layers. Whereas for liquid, it is like this. Still closer. Liquid is still closer. It's just that the arrangement is not regular. This one, you see, nicely arranged. This one is like Chin-Chai stand. They just simply stand. And then your balloon one is like this. Just keep it simple, guys. Keep it simple. You don't need to be an artist to draw this. Come on. All right. So stone is a solid, and coffee is a liquid, right? And then your balloon is a gas. All right, so moving on. Oh yeah, last time our students asking me, sir, Is honey a liquid? Is water a liquid? Yes, they are both liquid. But why is it different? Why is honey so sticky? Why is water so watery? This one, you will learn it in university next time. That is called viscosity. Viscosity. How easy something flows, it's called a viscosity. All right, like water is very viscous because they're very watery. Wait, sorry, viscosity is the stickiness. Sorry, I got it in reverse. So water is not viscous. That's the word, viscous. Water is not viscous because water is very watery, whereas your honey is very sticky. So that's your viscosity. All right, so still liquid. They are both still liquid. It's just that one is much more stickier. Okay, so anyway, so B, state the arrangement of particles for stone and balloon. So they want you to state the arrangement. How are they arranged? So for this stone, how are they arranged? They are arranged. No need to write arrange since they already state the arrangement. So they are close. Okay, they are all very close. Okay, I'll just say very close. And then for balloon is very far apart. Okay, very far apart. This is very close, this is close, this is very far apart. Gas, they just run everywhere. And then C, state the difference in the movement. Okay, now they want the movement. So is solid moving? No, they just vibrate. So they vibrate at fixed position. So they are not running everywhere. Okay, they just vibrate. They don't flow. Whereas for your where is Q? Stone and balloon. Okay, stone and balloon. All right, so balloon, they move randomly and collide with each other. Okay, collide means langgar. That means they bang into each other. They collide. It's just like a bumper car. So they just move randomly. They collide. So liquid, they don't collide. Liquid, they just slide. Okay, they just slide like that. Whereas gas, they just collide. Because gas is very excited, as you can see, all the atoms here, they're very excited. Very high energy. Very high energy. That's why the temperature is different. You see, solid is usually very cold. Liquid is hot. Gas is very hot. All right. If I take boiling water and spray it to you, yes, it's very painful. But I use steam to spray it to you, it's more painful. Because you see, water, the hottest they can be is 100 degrees Celsius. Whereas steam is above 100. If you got sprayed by steam, that thing can be easily 130, 140 degrees Celsius. You get even more painful. You get even more burn on your skin. Because they have more energy. They're more excited. They have more heat. That's how they hurt you more. All right, so D, explain why balloon is easier to compress than stone. All right, as I said, whether you can compress something, it depends on the space. Right, so why is a balloon easier to compress? Okay, because it has more space in between particles. All right, as you can see, a lot of space here, no space here. You see, solid is all nicely arranged. You cannot push them further in. Hey, can you go in a bit? I want to sit. I want to go on to this bus. No, sorry, the bus is fully occupied. You cannot press them in some more. So E, explain why a stone has a definite shape. So why is a stone, which is a solid, it doesn't change shape? Because the particles are hold together at a fixed position. Okay, particles are at fixed positions, right? They're standing very rigid at a box. They cannot just simply flow, not like liquid. Liquid can just flow. So that's why they have definite shape, right? You can't change the shape of a liquid, of a solid. So explain why coffee can flow. Okay, like I said, particles can slide over each other easily. They can just slide like that. That's why they can flow. All right, as you can see, every answer here, it's found in the box here. This box here. As long as you can understand this box, all right, that means you can answer your question. Okay, so sir, does it mean I have to memorize this? Yeah, but how is this memorizing? This is all common sense, right? I don't know lah, for me lah. Okay, at least for me it's common sense. So next G, let's finish this and we shall sign off. So classify the following substance into solid, liquid, gas, and at room temperature. So at room temperature, don't come and argue with me, sir. I thought this thing can be liquid. Yes, they can. If it's hotter, then yes. Room temperature is 25. Okay, 25 to 27, that's the room temperature. So number one, charcoal. You know what's a charcoal? You use this thing for barbecue, that black color thing. So that thing is a solid. All right, charcoal is a solid. Next, steam. Steam is a gas. Steam is a gas. Right, steam one. And then next, hydrogen. This is a gas too. Hydrogen is a gas. It's a very explosive gas. Okay? Hydrogen can just explode for no reason. So don't mess with this thing. Next, ice. Obviously, ice is a liquid. Sorry, it's a solid. You may say, but sir, ice will melt. Yes, they will melt, but we are talking about when they're not melting, they're ice. Right? So next, petrol. Petrol is the thing you put in your car, petrol station. The thing is a liquid. Next, kerosene. What is kerosene? Kerosene is the friend of petrol. Where do you find this thing? Kerosene is in your paint thinner. You know paint thinner? You know it's a paint thinner. When your dad paints the house, he will get a bottle of clear fluid called kerosene, paint thinner. The thing can be used to, if you accidentally painted over some unwanted surface, for example, if you accidentally painted over the cabinet, so how can you clean the extra paint away? You use a paint thinner. So that's a kerosene. All right. This thing smells bad. Kerosene and petrol, they almost have the same smell. You know the smell at petrol station? That very strong, pungent smell. That's the petrol smell. All right. So sulfur. Sulfur is a yellow powder, so it is a solid. All right. They used to sprinkle this thing around houses last time. Last time in kampung, in villages, they used to sprinkle sulfur around the house to stop snakes from coming into the house. Because snakes are scared of sulfur. All right, so next, mercury. That silver color thing in your thermometer, the thing can flow, right? So that thing is a liquid. Okay, so I think we have done this question. Yes, we have. So I think I'm going to stop here. All right, so thank you guys for coming, although it's a holiday. So next week, we shall finish this chapter. So next week, we will talk about the change of state. All right, so thank you guys. Have a happy Monday. Good night to you. I will see you next week. All right, so take care. See you. Good night. Bye-bye.